Hello friends, I welcome you all to the course Marketing Research and Analysis, the second part. In the last class we have been discussing about the various kinds of experimental statistical designs. For example, we covered tests like ANOVA, MANOVA, MANCOVA, ANCOVA, right, and we tried to understand from one way and n way point of view, right. So, when there is only one factor or more than one factor. But after that today we will learn something about one of the most important aspects in real life that you face is relationship or association between two or more variables. Okay. What is the importance of understanding this? Now, let us think of a situation when the temperature increases, right, we tend to buy air coolers, and fridge or water coolers and all, right, so that we can satisfy ourselves. So, what is this relationship? So, this relationship is that with increase in temperature the need for cool or coolness increases. Similarly, when you exercise you tend to drink more water, right. Similarly, when somebody is let us say afraid, he will speak more mistakes or he will make more mistakes while speaking. So, he will tell one lie after another. So, all these things are sometimes directly visible, sometimes not directly visible, but there are correlation, there are relationships or association between two or more variables, and by understanding these associations that is present in nature and around you, we try to unearth several new knowledge. Okay. So, today one of this that we are talking about is one of these association is called covariance and correlation. Now, this is something which looks very simple, and it is simple by the way, but then there is some doubt in people's mind whenever I talk to students. I have seen there is a difference, there is a in their thought they are not very clear what exactly a covariance and a correlation means and how they are different and how they are similar. Okay. So, today my job is to do that, to make it clear to you. So, let us see what is this covariance first. Let us start with covariance, right. So, what it says is covariance is used to measure variables that have different units of measurement. Now, let us understand, we have two variables which are different, you have different units. Okay. So, one may be for example your height which is measured in centimeter, and the other may be your weight which may be measured in kilogram, right. So, if I am measuring two different variables with different sets of units, then in that case we want to see how these two variables are affecting each other or they are moving with each other, right. So, by leveraging covariance, researchers are able to determine whether these units are increasing or decreasing. That means in simple terms the direction, we are talking about the direction. Okay. So, how are they moving, in which direction are they moving. Okay. But what is the problem? They are unable to solidify the degree to which the variables are moving together. Why? Because covariance does not use one standardized unit of measurement, right. So, the problem is that since covariance does not use one particular unit of measurement, and there are two different, for example, in case of height and let us say weight. So, this is let us say centimeter and this is kilogram. So, something when I do a covariance, that means when I do a covariance between height and weight, so finally my unit that will come is centimeter kg. So, which is quite absurd to understand or redundant, it looks redundant, right. So, that is why it becomes very difficult to solidify the exact degree to which the standard units are the variables are moving together, but it only helps you to tell the direction whether they are moving positively or negatively. Okay. Example, investigate the relationship between exercise hours and blood sugar. So, a researcher wants to know, is there any relationship between exercise hours and blood sugar. Now, such kind of relationships do exist in real life, in nature, everywhere. So, let us see. So, this is some 5 respondents have been taken, the number of hours they are exercising is given to you and their blood sugar level. So, you might just take it as an arbitrary number because blood sugar might be measured in some different numbers, I do not know, more than 100 or something. So, just forget it, take it as just a number. Okay. So, so as it is 0, it is 45. Somebody who does not do any exercise, the blood sugar level is 45, right. When it is 5, it is 42, 10, 33. Here we are assuming that exercise is only the reason behind the blood sugar, but there might be several other extraneous variables also which we have not taken into account here. Okay. Now how does it look if we plot it? Now let us say this is how it will look. So if I do this, so 25, 30, 35, so as my blood sugar is let us say at 45, what is my exercise? Well, it is at 0, let us say this is 0 point, right. So this is 5, 10, 15, 20, right. So you can see that there is a continuous fall. Okay. Observe that as exercise goes up, corresponding blood sugar goes down. Okay. The variables co-vary, but how do they co-vary? Inversely. That means when one goes up, the other goes down. Now what is this then, the relationship between covariance and correlation? Actually covariance and correlation are same thing, you can understand they are the same thing, the slight difference exists in between them, that covariance does not is not able to give you a comparison between let us say two different variables, right, because it only tells you the direction, but correlation not only tells you the direction, but also tells you the degree of the relationship, right. So let me show you how it is done. So first let us understand the covariance little more. For similar to variance, now this word has come from the word variance. I hope you understand what is variance. So how do you measure variance? Variance is nothing as square of standard deviation, which is given as x minus x bar square, x minus x bar square summation by n minus 1. So this is the formula for variance, right. Similarly covariance means when two variables are covariant. Which are the two variables? The x and the y. Okay. The formula is x minus x bar into y minus y bar divided by summation of it divided by n minus 1. Okay. Now let us take the same case. So 0, 5, 10, 15, 20, blood sugar is this much, and how do you calculate? So x minus x bar. So what is my in this case what is my x bar? 5, 10, 15, 30, 40, 50 divided by 5. So my x bar is 10, right. Similarly my y bar is equal to how much? Well 40, 40, 80, 30, 110, 140, 160, 170, 175, 180, 180 divided by 5. So how much it is? 185, 36, right, 36. So now we can calculate x minus x bar. So first is 0 minus 10 minus 10, 5 minus 10 minus 5, 10 minus 10 0, 15 minus 10 5, 20 minus 10 10. Similarly for sugar y, 45 minus 36 9, 42 minus 36 6, 33 minus 36 minus 3, 31 minus 36 minus 5, 29 minus 36 minus 7. Okay. Now we multiply together x minus x bar into y minus y bar. So this is giving us how much? Minus 10 into 9, 9 minus 90, minus 5 into 6 minus 30, 0 into 3 0, 5 into minus 5 minus 25. The summation of this together gives us minus 215. Okay. Now if I take this, so x minus x bar into y minus y bar, so there is minus 215 divided by 1 by n minus y, n was 5, so 5 respondents, so 5 minus 1 is equal to 4, right. So my covariance value now is equal to how much? Minus 53.75. So the covariance between exercise and blood sugar is minus 53.75. Since the covariance is negative, the variables are inversely related, they move together in the opposite direction, that means one goes up, the other goes down, right. Since the variables have different units, it is not possible to measure the degree which is done with correlation. So this is not possible here. Let me show you one more example. Let us say you want to measure compare the relationship between you know that when age increases people's weight increases. Similarly when height increases also the weight increases. So suppose we want to take a relationship between height and weight and let us say age and weight, right. So if I do this, let us say if I do this and I find out well this is the relationship between height and weight is something, some value we have got, let us say when we take height as x, let us say weight as my y, similarly then I get some value, this covariance value. Similarly, when I take age as my x and y my weight, then I am getting another value. So, you see now, so here my units would be like what, height is centimeter kg, and this is years, suppose age is in year and kg. Now, just look, can I compare these two? Well, no, I cannot. Why? Because they are completely absurd different units, right. So, that is what it is saying. So, how do we go ahead? Now, here then comes the use of correlation. Now, let us see correlation. As the summer heat rises, hill stations are crowded with more and more visitors, okay. Ice cream sales become more active. So, the temperature, that means we can say the temperature is related to the number of visitors visiting the place and also the sale of ice creams. So, if the temperature is increasing outside, so people try to visit the hill stations which is more cooler, and the consumption of ice creams also increases because it is hot outside. Similarly, as the supply of tomatoes increases in your local market, its price drops. When the local harvest starts reaching the market, the price of tomatoes drops from a price of rupees 40 per kg maybe to rupees 4 per kg or even less. So, the supply is related to price. So, that means these are all things that we know they are associated. So, these associations are very important for us to understand in real life. Okay. So, what is this correlation saying? Correlation analysis is a means for examining the relationships in a systematic manner. Okay. It deals with several questions. What are the questions? Is there any relationship between two variables x and y? Is there any relationship? Okay. If the value of one variable changes, suppose x, does the value of the other changes? That means, if x changes, does y also change? Do both the variables move in the same direction or opposite? That means, if x goes up, does y also go up, or if x goes up, does y go down? So, what is the which relationship comes? How strong? What is the strength of the relationship? Is it, let us say, a very strong relationship, then we would say it is +1. If it is a very weak relationship, it is -1. If it is no relationship, it is 0. Okay. So, correlation studies and measures the direction which covariance was also doing and intensity of the relationship among the variables. So, it is helping you to not only understand the direction, but also the intensity. Now, how is it doing that? So, we will see that. Correlation analysis deals with the association between two or more variables. Okay. The measure is called the correlation coefficient given by R, and this ranges from -1 to +1. The direction of change is indicated by a sign. Okay. Now, this example, but before that let us understand, when you talked about covariance. So, in covariance, when how correlation is measured? Correlation takes covariance divided by covariance of x and y divided by standard deviation of x by standard deviation of y. So, when we are doing this in one way, the correlation helps you to standardize the values and bring it to a range of -1 to +1. So, anything that is now, anything that you are doing with any kind of variables, they all are in a range between -1 to +1. So, now since they are of now it has become unitless. Okay. So, since it has become unitless, you can easily compare it. Okay. A study suggested that a strong correlation existed between high willingness to undertake risk, right, and strong performance in the stock market. That means, people who are more risk taking, they do well in the stock market, right. So, some other examples are like, is there a relationship between a person's education and their health? That means, if people are more educated, does it have a relationship with their health? Could be that some people might argue that people who are educated, they are more conscious about their health, right. Owning a pet, is it associated with living longer? Like in some countries they say, if you own a dog or a cat, it helps you to live longer because you are more compassionate, you are more kind. So, these are positive traits which help you to live longer, right. So, there are less heart attacks and all. Did a company's marketing campaign increase their product sales? So, we want to see such associations. Okay. So, what is the difference now? Let us come back. Covariance can take on practically any number while a correlation is limited to -1 to +1. Therefore, it is said covariance lies between plus infinity to minus infinity, right, and correlation lies between -1 to +1, right. Covariance does not tell us the intensity, only the direction, because covariance measures variables of different units. It has numerical limitations. Obviously, different units are there, centimeter and kg, right. Correlation is more useful for determining how strong the relationship is between the two variables. Okay. It is not affected by changes in the mean, it is not affected by the changes or the scale of the variables, okay, because it is standardizing them. We can standardize the covariance, however, and calculate the correlation coefficient. So, the similarity is that both are doing the same thing, but the difference is that covariance is an unstandardized value and correlation is the same value which of the covariance which has been standardized now, okay, which will tell us not only the direction, but provide a scale to estimate the degree to which the variables move together. So, that means in real life this becomes a more powerful tool out of the covariance and correlation. The correlation becomes a more powerful tool for us. Okay. Now, what is correlation and causation? So, two variables are correlated. So, that we understand as there is a correlation, but what is causation? Let us understand. What is we have understood correlation, it says a statistical measure that describes the size and direction of a relationship, right. A correlation between variables, however, does not automatically mean that a change in one variable is the cause of the change in the values of the other variable, right. That means, if one variable changes, automatically it affects the other. So, that it does not say, but whereas what is causation saying? It indicates that one event is the result of the occurrence of the other event. If this event would not have been there, the other would not have happened, that is what it says. That is, there is a causal relationship between the two events, right. As you have studied, if I remember concomitant variation, when I was talking about concomitant variation, when I was teaching ANOVA, at that time we said how two variables are affected. We cannot say after it has happened the any variable, the role of any variable at the same time, two variables A and B at the same time, how they are varying. Okay. So, this is also referred to as cause and effect. Causation always implies correlation. Causation always implies, if there is a cause, there is a correlation, but correlation does not necessarily imply causation. That means what? If there is a correlation between two variables, that does not necessarily mean that one affects the other or one is the cause of the other, right. But if there is a cause and effect relationship, that means there is surely a correlation between them. I hope you understand this. Causation leads to, means there is a correlation, but a correlation only does not necessarily mean that there is a cause and effect. Okay. So, theoretically the difference between the two types of relations are easy to identify. An occurrence, action or occurrence can cause another. See, smoking causes an increase in the risk of developing lung cancer, or it can correlate with another. Example, smoking is correlated with alcoholism, but it does not cause alcoholism, right. We can say smoking and alcoholism are related. We have seen people who smoke, they are more the chances of their consuming alcohol is more than a person who is not smoking, right. Or we can connect with alcoholism and non-vegetarian food. People who are fond of non-vegetarian food, maybe I am not trying to put forth an argument, but maybe the chances are that in India at least we have seen that these people are more prone to have a taste for alcohol. So, but that does not mean if somebody is eating non-veg, he will, that is a cause for becoming consuming alcohol, right. So, that is what we were trying to discuss in the last slide. In practice, however, it remains difficult to clearly establish cause and effect compared with establishing correlation. Cause and effect is very difficult to establish, but correlation we can find out the types of correlation. So, basically there are two types of correlation, positive and negative. So, positive we understood, if the two variables x, y are positively correlated, if x increases, y increases, right. Negative correlation, if x increases, y decreases, right. So, if x, y, right. Now, the correlation is said to be positive if the two values, if the values of the two variables changing in the same direction. Public expenditure and sales. So, if public expenditure is increasing, sales is increasing. height is increasing, weight is increasing, right. Negative. The correlation is said to be negative when the values change with opposite direction. Price is increasing, quantity demanded is decreasing. This is the case, right, and the first one, this is the case. Okay. As x is increasing, y is increasing. As x is decreasing, y is decreasing. This is also a positive relationship. That means what? They are moving in the same direction, right. But negative, you see, as x is increasing, y is decreasing. X is decreasing, y is increasing. So opposite, right. As TV time increases, grades decrease. I do not know whether students will agree to this or not, but this is a fact. Okay. Now, how do you define correlation in other ways? Let us see. Simple correlation and multiple correlation, right. So, simple means the relationship correlation between two variables, right, and multiple means where we have more than two variables and we are trying to establish a relationship among the 3 or 4 or 5 whatever it is, right. So, let us see this simple correlation. Under simple correlation problem, there are only two variables studied, relationship between sales and advertisement. Multiple correlation, 3 or more than 3 variables are studied, at least 3 or more than 3. Quantity demanded of a product is a function of price of the product, price of the competitor's product, income, supply of the product. Now, you see how many variables are there? Quantity demanded of a product is saying is a function of price. So, quantity demanded is associated with price of the product, price of the competitor's product, income of the people and the supply of the product available in the market. So, 1, 2, 3, 4 and 5. So, there are 5 variables and suppose we are measuring a correlation, and by measuring a correlation here we can say which two are most highly correlated, which say quantity demanded has the highest correlation with price of the product or price of the competitor's product or income of the person or the supply in the market. Okay. Third is a partial correlation. This is also equally very important to understand. What is this partial correlation? Many a times students ignore and or they just miss it out, but that should not happen. What it says is it recognizes more than 2 variables, but considers only 2 variables keeping the other constant. That means suppose there are, in this case there are 4 variables, let us say this is the one which is the main and the rest are affecting it, we want to see the correlation. Now, suppose I want to see the correlation between quantity demanded and the price of the product, let us say, but and I will keep these things as I will just suppress them, right. In that case I am doing a partial correlation. Example, you see relationship between fertilizer and crop yield keeping the weather conditions constant, or you can just say you are suppressing the weather condition. So, here similarly we are suppressing the price of the competitor's product, income and supply. So, when I do this, it is a case of a partial correlation. So, you can do once for let us say quantity demanded and price of the product, then you can do one for 1 and 3 keeping 2, 4 and 5 as my suppressing the 3 variables, or you can do 1 and 4 keeping 2, 3 and 5 constant. Similarly, 1 and 5 keeping 2, 3 and 4 constant. What is this total correlation? Is based on all the relevant variables, which is normally not feasible. Okay. So, let us see what is exactly meaning of that. So, types of correlation: correlation, linear and non-linear, another way of understanding linear and non-linear. So, you understood simple, multiple, partial, now understand it from a linear and non-linear point of view. Linear is very simple, we have understood when the amount of change in one variable tends to bear a constant change or a constant ratio to the amount of change in the other. If there is a suppose 1 unit change here leads to 2 unit change there. So, in the second case 2 unit changes here leads to 4 unit changes there. So, when I am doing this, it is a constant ratio, right. So, the graph of the variables having a linear relationship will form a straight line, you see. So, 1 2 2 4 3 6 4 8 5 10 6 12 goes on. But what is this non-linear relationship? The correlation would be non-linear if the amount of change in one variable does not bear a constant ratio to the amount of change in the other variable. In fact, in life most of the relationships are not linear, right, although we assume them to be linear for a statistical to make it statistically simpler to simplicity, but they are not linear. For example, you see crime and population density. So, as it is, you see the measure of population density is increasing, the number of crime is increasing, but the increasing rate is not linear, right. So, it is increasing at a, let us say in the initial period at a very high pace, but then after that the pace is slowing down, okay. And it could be also possible that after certain time it may even come, it may fall down, right. So, this non-linear correlation, right, says that the correlation would be non-linear if the amount of change in one variable does not bear a constant ratio to the amount of change in the other variable. So, that means the relationship could be just a a non-linear, that means, so here it could be for 1 it is 1:2, in the second case it could be 1:5, it could be 1:3 into 1:4, or it could be an exponential growth, right. So, when we are having such kind of a relationship, we say it is a non-linear or a curvilinear relationship, right. So, when there is a curvilinear relationship, when I move from a correlation to regression, we will also be solving problems on that, right. And that is very essential to understand that most of our relationships in life might not be linear, okay. So, this is how you see this. So, this is a linear correlation and this is a non-linear or curvilinear relationship. Well, today I will just stop it here. In the next lecture we will continue further with the correlation, and we will try to understand how to solve a problem, how to solve a problem for a correlation problem, how to solve a correlation problem, and understand and the concept of regression further, the dynamics of regression and its use in real life, right. Well, thank you so much, thank you for the day.